Welcome to our tutorial on slope. Slope tells us how fast a variable changes as another variable increases. Usually we use x and y. Today we are going to discuss how to find the slope of a line given 2 points on the line. This is a basic concept that's essential to understand in order to graph lines, to interpret graphs of lines, and to apply linear functions to practical situations that involve some sort of linear relationship. What is slope? Slope is a measure of how fast a line is increasing or decreasing as it moves from left to right across the coordinate plane. It's the y-coordinate's rate of change as x increases. Finally, we use the letter m to represent slope. So, how do you calculate slope? Well, first of all, you have to identify 2 points on the line. We'll use two general points, x sub 1, y sub 1, and x sub 2, y sub 2, for our example. The slope of this line would then be given using the equation y2 minus y1 divided by x2 minus x1. So you see here we're subtracting the y-coordinates and then we're subtracting the x-coordinates. And one of the keys to setting this up properly is that whatever point you use the y-coordinate from first, you have to use that point's x-coordinate from first in the denominator. Now it doesn't matter which point you call x sub 1, y sub 1, and x sub 2, y sub 2, but it does matter that you are consistent when you set up your formula. So, what kinds of slope are there? First of all, there's positive slope. I like to illustrate this with an airplane. As we see an airplane take off, it's increasing in altitude. So as this plane flies across from left to right, we're increasing, we're going up. Our y-coordinate is increasing. Let's look at an example of this. Suppose we have the points 2, negative 3, and 5, 4. So here we have the point 2, negative 3, and we have the point 5, 4. Using our slope formula, y2 minus y1 over x2 minus x1, we can plug in the coordinates of this point, of these points, negative 3 and 2. Notice I used the same y-coordinate and x-coordinate from the same point first, minus the y-coordinate 4, and in the denominator we have minus the x-coordinate 5. Now as we simplify this, we get negative 7 divided by negative 3, which of course is a positive 7/3. So we would say that the slope is 7/3. Now there is an alternative form of this formula that is a little better for those of you who might be more of a visual learner. The alternate formula uses the terms rise and run. Rise means how much our y-coordinate changes, or how far we go up from one point to the other, and run tells us how far left to right we move. So as you can see with these 2 points, to go from one to the other we're going to rise 7 and then we're going to run 3. Hence we have the slope 7/3. Now another kind of slope is horizontal slope, which is 0. It's equal to 0. Now notice here we have our plane, it's taken off, and now it's just cruising. We're not going up and we're not going down. The value of y is not changing as x increases, or as we go from left to right. Let's look at an example of this one. We're going to find the slope of the line through the points 2, negative 3, and 5, negative 3. Notice we have a horizontal line. Again, we'll start with our formula for slope, y2 minus y1 over x2 minus x1. And we'll plug in our coordinates. Now do be careful, we have a negative 3 for a y-coordinate, but we still have to make sure we subtract it. This will produce a double negative, and as we simplify, we'll have negative 3 plus 3, which turns out to give us 0 over negative 3, which indeed equals 0 as we expected. So here we have a horizontal line and it has 0 slope. We are neither increasing nor decreasing. Considering rise and run, we can see that this line will rise 0 and run 2. Now, another form of slope is negative slope. The value of y is decreasing as x increases. Here we have a plane. Using our plane illustration again, we're coming in for a landing. It's decreasing in altitude as we go from left to right here. So we have a negative slope. Let's look at an example here. We have the point 38 and 5, negative 2. Again, starting with our formula, y2 minus y1 over x2 minus x1, we take our y-coordinates 8 and negative 2 and we subtract them. And then we take our x-coordinates 3 and 5 and subtract them. Again, we have this double negative because we had a negative 2 for our y-coordinate. So x plus 2 will give us 10, and 3 minus 5 is a negative 2. Then, of course, we can divide, and notice in this case we got an integer, it's negative 5. And the way you could think of this in terms of rise and run is that we are going down 5 for every 1 we go over. In other words, we rise a negative 5 and we run 1. To use the 2 points that we were given, we would think of it in terms of rising negative 10 and running 2, which of course would reduce down to negative 5 over 1. Our final kind of slope is something that you never want to do with an airplane, and that is when we have a vertical line. You have a vertical line, we have what's called no slope. As you can see, this plane is not going to be flying anywhere anytime soon. So we have no flights scheduled. Slope is undefined because the value of x does not increase. It ruins the whole definition of what slope is. Slope is the change in y as x increases, but here x is not changing. Let's take a look at an example of that. Here we're going to find the slope of the line through the points 5, negative 3, and 5, 4. So again, I use my formula. I plug in the points, negative 3 minus 4 over 5 minus 5, and here we have negative 7 divided by 0. And of course we all know that you cannot divide anything by 0 because you can't take something and put it into 0 groups. So we would say that the slope here is undefined, or we could say that there is no slope. As you can see here, we rise negative 7 and run 0. Okay, so that's the fourth and final example of different type of slope. But why is slope so important? Slope actually has thousands of applications. It includes the pitch of a roof, road grades, speed, simple interest, wheelchair ramps, population growth, hourly pay. In other words, anytime something is growing at a constant rate, whether it's the height of your roof, the altitude of your road, the distance that you've traveled in a car, the money that's earning interest, or the height of your ramp, or the size of a population, or the amount of money that you've made, you can think of that in terms of slope. So, why don't you take some time now to practice finding slopes for yourself?